This is a presentation about Substrate. I'm going to give a short intro about myself, followed by my colleague Martin here. So my name is Georgi. I've been in the sphere for about 3 years now. I've worked with names such as The Graph, Starkware, and of course Polkadot. I'm currently building a node built on Java for the Polkadot ecosystem. And in this presentation, we'll show you the basic and the fundamentals to Substrate. I'll give my colleague Martin here also a few minutes to introduce himself, and we can begin.
Thank you, George. So I'm Martin. I'm working as a team lead in LimeChain and as a mentor in Lime Academy. I'm working in LimeChain for about 3 years, worked on a couple of different projects. Most of them are related to DeFi, on Ethereum network, and on Hedera ecosystem. And today I'll be helping George for this nice presentation. So back to you.
Yeah, thank you. And let's begin. So first off, what is Substrate? Well, Substrate is a SDK for building blockchains, to put it simply. It's currently the primary way for building parachains. Now, my guess is that most of you know the difference between a standalone chain and a parachain, but I'm going to explain it regardless for anyone who doesn't know. So a parachain is a chain that has been attached to the relay chain, so that you can replace relay with main here. So like the main chain of the network, it can be Polkadot, it could be Kusama. The important thing there is that the moment you attach yourself into a relay chain, you follow relay rules. So what that means is that you use their security, so their validators, but you also, when you want to make a state transition, you have to follow the information that's given by the relay chain. So you are dependent on it, but it takes care of a lot of the work. So one of the things that many people struggle with when building a blockchain is building a secure blockchain. So what that means is that in order to have security, that there are no faulty validators, or even if there are, that they're not a large enough number, usually you would need to have a large network for that to happen. And building a large network from nothing is usually very hard to do. This is where Substrate comes in handy, and allowing you to create this parachain that you can plug into the relay chain, fixing all of those problems, giving you the shared security of Polkadot. Okay, so if we're going to talk about Substrate and what it can offer, first off, I want to take just a minute to go over this image I've chosen here. This is an alien from the Ben 10 animated series. I was really struggling to pick a picture that's right for this slide, but I think this alien just does it all. It's an alien that can change any type of technology into any other type of technology that you want. Much like Substrate can morph your blockchain into exactly the blockchain you want. So without further ado, let's look at the blockchain components. So here we have a list of components that exist in every single blockchain. This list is not complete. Those are not all the things that make a blockchain. Those are just some of the most fundamental and important to understand. So first off, we have the P2P. This is a peer-to-peer connection, absolutely necessary. Nodes need to communicate with each other, to exchange proof, to exchange data, sometimes to gossip, depending on the protocol. Yeah, absolutely necessary. Consensus, this is how nodes determine which blocks are valid and which blocks are invalid, which should be added to the blockchain and which should be completely rejected. This is also absolutely mandatory for every blockchain. Block authoring is the idea that some nodes have the power to create a block and offer that block to be added to the blockchain. Obviously, it's called a blockchain, so block authoring is a big part of the whole process. And fork resolution, probably one of the more interesting things here, refers to the fact that sometimes when you have multiple nodes validating multiple block offers, sometimes you can have two block offers that are being approved at the same time. And then the network doesn't know which block to choose from, doesn't know which is the correct next block because they both passed the validation step. So how are those forks resolved? Well, the network usually waits for the blocks to become a larger sequence of blocks. And then when you start comparing them, you just choose the longest fork, and you add that to the blockchain, invalidating the other proposed solutions at that point. This is very important because it happens constantly, given that most things in the blockchain are asynchronous. And the last, but definitely not least, component is the runtime. In Polkadot, the runtime is the one that's responsible for the state transition. So every time you want a transaction to be correctly executed, every time you want a block to be added, that needs to go through the runtime. You don't have a choice there. And so after we've listed all of those, the main purpose of listing them was to tell you that Substrate gives you all of those things ready for use. So you can just imagine how much work that saves for creating a new blockchain. And one of the more interesting components we are going to be looking at today is Cumulus. Now, Cumulus is very, very important when it comes to creating parachains. By very important, I mean absolutely mandatory. It is the link between Substrate and Polkadot, and you need to implement the Cumulus validation functions in order to be able to plug your chain into the relay chain, making it a valid parachain at that point. So the validation function is a function that accepts a block header, a block data, and a state of the blockchain as arguments. And it internally just validates those. It determines, is this a valid block? Is this a valid block header? Is this a valid continuation of the chain? And if all those questions are answered truthfully, or I should say positively, then that block is considered valid. This is one of the main things that Cumulus does for you. This is what's saving the need to implement your own type of security in your blockchain. The validation function is what's allowing you to use the validators from the relay chain of the network. And yeah, if you want to make your chain compatible with Polkadot, you want to plug it in, you absolutely need to look at Cumulus. It's, yeah. So the next big thing, and probably the biggest thing in this whole presentation, are the frame palettes. So what these frame palettes do is they give you a bundled up functionality that's already ready to use. You just need to choose which exact palettes you want to be included in your blockchain, and then Substrate can generate the blockchain you want together with them. So what are the types of palettes that could be added? Well, the main types are three. We have the system palettes. The system palettes are integral to the runtime, provide core functionality, and all of the other palettes depend on them. So the system palettes, they're few but very important. We have the functional palettes. Now, those are the many palettes that you see here. Most of them are functional palettes. These are palettes that are completely optional, and you can add how many of them you want to in whatever configuration you want. I don't have the time to go through all of them one by one just because there are so many. But just to give you a quick idea of what we're talking about here, we have something like balances palette. The balances palette is absolutely necessary if you want your blockchain to have a cryptocurrency attached to it. So if you want to have like accounts which have balances, you need to import the balances palette. You have the Babe, Aura, Grandpa. Those are the top three that you can see in the image palettes. Those are all consensus algorithms. So Babe is responsible for block authoring, Grandpa is responsible for finality. And you can choose if you want to use both of them, just like the Polkadot nodes do, or if you want to use just a portion of them and implement the rest in your own logic. The contracts, I will mention one more functional palette just because it's very important. We have the contracts palette. It's currently not selected in this image, but what it allows you to do is to write smart contracts in Polkadot. So this is not a thing that was supported from the start of Polkadot. It's something that's being built on as we speak, and we have a slide further down the way further explaining how to write these contracts. But yeah, there are a lot of other options like elections, multisig, democracy, and so on and so forth. They're all very well described in the documentation, and you can just look it up and see which ones fit your case the best. Now, the final type, because at the beginning I said that there were three main types of palettes, and we already talked about the system palettes and the functional palettes. The final type of palettes that exist are the parachain palettes. Those are the palettes that you need to absolutely implement in order to have your chain be attached to the relay chain, therefore becoming a valid parachain of the network. Now, when you hear parachain palette, always think Cumulus. That's what Cumulus is for. Most of the palettes, if not all of them, have Cumulus in their name even, that are part of the parachain palettes, and they are not mandatory to use. That's also an important distinction. A lot of people think that there is a dependency between Polkadot and Substrate, but the truth is they're completely independent of each other. So what that means is that, first off, you can have a chain be created on Substrate that's not a parachain, that's working as a standalone chain. And at the same time, you can have a chain that's not created with Substrate and yet is a parachain in the network. Now, that's a bit more complicated to do, and you have to have some very specific use case to go there, but it is possible. That's what's important to know. They're completely independent of one another. One quick thing about the Substrate is that Polkadot, the initial relay chain, was also developed using Substrate, so that should attest to how well it's made and how much it's used in the ecosystem. With that out of the way, we can go to the next part. And here we have ink. Now, ink is, as we mentioned before, there is a way to write smart contracts in Polkadot. Ink is that way. Ink is a programming language specifically for smart contracts that was not built from the zero, so it's not like a Solidity type of language where you need to learn everything from the start. It's derived from Rust, so as long as you know Rust, you automatically know ink as well. That's one of its main selling points. It also is very fast. It compiles, when it's compiled, it's very fast. The picture you see here is of different types of palettes. So elections, identity, assets, all of those are different types of palettes. Just to make, just to give you the idea that ink and the smart contracts palette is just a very, very, very small thing in a very large ocean. I don't know the exact phrase for this. I'm going to be showing you how a ink contract looks, just to give you an idea of just how similar it is to Rust. Here we have an ink contract that's an ERC20 contract. So it's basically the ERC20 contract from Ethereum translated into ink. So here you can see that we have things like the ink contract annotation on top, but everything else just looks like complete Rust. We have the struct here, the definition with the types. Further down the file, we can see different types of events, the approval and transfer event. We can see different types of errors, the insufficient balance or insufficient allowance errors. And so the three things that are currently defined in the ERC20 struct are the balance of a person, a mapping to the owner and the amount of tokens owned, and another mapping for the allowances to know if someone else is allowed to take money from that account. So if we scroll down, we can see that just like in Rust, we have this impl followed by the struct name to implement any functions you want this struct to support. So the first public function we have is obviously going to be the constructor, so that this struct can be constructed somehow. The only things it takes as an argument is the total supply. Everything else happens under the hood. We have other functions that are publicly available, such as balance of, total supply, and so on. And if we scroll even further down, we can see that we even have the implementation of the functions transfer from. And you can see by the size of this code, this is not a complicated contract to read, right? You have a account ID from, this is the sender of the request, this is to is the receiver of the transfer, and value is obviously going to be the amount that's sent. As you can see here, we do some checks to see if the allowance and the value are the same or not enough and whatnot. And if everything is all right, we call the transfer from to, which is the function down here. It accepts the exact same type of parameters, checks for the balance, and just does this small operation. And there you have it. The rest of the contract is basically tests. So yeah, not much to go on there. But yeah, it's very easy to write contracts in Ink if you know Rust. So yeah, learning Rust has this bonus application of allowing you to write contracts easily with Ink.
So very convenient to have the tests inside the contract itself.
Yeah, it's just common practice in Rust.
Nice.
Okay, so back to the presentation we go. The next big thing I want to talk about a bit is Frontier. So Frontier is the bridge to Ethereum. It is the only type of compatibility layer that's currently available for the Polkadot ecosystem. You need to implement a couple of packages to make this work. I think it's not only the Ethereum palette, but also the EVM palette. And yeah, what this allows you is the access to all the Ethereum RPC APIs. And you can build your own dApps in your favorite Ethereum tools just by connecting the Polkadot to the Polkadot to Ethereum. Now, this is not as basic as the other stuff we have discussed. So when it comes to things like frame palettes and cumulus and so on and so forth, you will need to go test out some things, just try it out in the playing ground, see what works for you. The Frontier part and the Ethereum compatibility, this is more of a bonus. So this, don't look at this as something you should mandatorily check. More so if you have a concrete idea that necessitates connection to Ethereum, then you should be taking a deeper look into Frontier. With that being said, the format of this presentation is that now we have basically covered most of the basic things in the ecosystem. So next up, Martin will tell you about more of the use cases of the product itself. And at the end, we're going to have a short demo about creating a blockchain on your local machine, and then what the next step should be for you. So yeah, Martin, you can take it away.
Thank you, George. Very interesting. So I'm going to show you a couple of use cases and interesting projects built with Substrate. So what are the main use cases? As you see, these use cases are kind of classical blockchain use cases as DeFi, decentralized finance, staking, which is kind of part of the DeFi, some Web3 infrastructures that could be file storage, mining, as well setting decentralized identity, governance, and even gaming. So the classical use cases like Web3 use cases. So one of the most famous project is an Akawa network. It's a parachain built with Substrate. It's a DeFi focused protocol. There is about $141 million locked into this protocol, 200K accounts using actively this network. And as you see, most of the classical DeFi use cases are covered here, like staking, bridging to another parachains, swapping tokens, liquid staking, which is a new modern paradigm in the blockchain industry, and governance, which is a classical voting mechanism. So another interesting project is a Juna or maybe a Huna network. Not sure how to read exactly. It's a project focused on building infrastructure for blockchain games. It features a couple of SDK which facilitate creating games. As you see, there are a lot of transactions, a lot of NFTs mint NFTs connected to the games which are built on this network, around 10K of active users currently. And one of the most popular projects on this network is awesome Huna avatars, which are profile pictures that you can buy and upgrade, and after that trade on a marketplace like a classical NFT marketplace. So another interesting project is BitTensor. It's a platform when you can create digital commodities. And these digital commodities, the main use cases are AI, of course, computing power, could be some financial instruments, again, DeFi related stuff, and other use cases, of course. So BitTensors provides a couple of components. They have an API, but the most interesting is the code, the so-called subnets, which are these exact components for use cases. So we can have a subnet for AI, subnet for mining, subnet for computer power, and whatever case in digital commodities we want to provide to the end user. So one of the maybe first project and parachains created by Substrate is Moonbeam. It's a decentralized and permissionless network, and the most interesting thing here is that it supports Ethereum compatible smart contracts. So as George mentioned, here we can imagine that this network is using the EVM and eventually smart contract palette in order to provide this native interoperability between Ethereum and Polkadot. So you can imagine that you can take a protocol which is built for the Ethereum network, and you can deploy it on this parachain, and it should work as the same way because there is this EVM compatibility and operability. So another interesting project is Centrifuge. It's again DeFi-oriented platform or blockchain with the proof of stake consensus focused on NFTs. With a very impressive TVL of almost $300 million and a lot of tokenized real-world assets. So here you can have a portfolio, you can stake and invest in real assets and have some nice APR based on that. Of course, there is a governance as every kind of respectable DeFi protocol. So another project is ChainX. It mainly works as a layer 2 scaling solution for Bitcoin, although it could be used as an interoperability protocol and supports a couple of wallets. They have a mobile wallet, especially for the Polkadot ecosystem, and coming chat wallet. So it's a company which is covering a lot of use cases relating of the blockchain usage. Another interesting use case is Fractal, which is building decentralized identity. Decentralized identity could be used, let's say, in DeFi, in as well in decentralized social networks, and a lot of other interesting use cases which facilitate the use of the blockchain as well. So another project related to governance, it's GameDAO. So it's a facilitate collaboration between blockchain games and facilitate the governance could be integrated in the blockchain gaming ecosystem, and they provide marketplace as well, when you can trade some game assets and do some collaboration as well. So that was for these are just the main use cases. Of course, there are tens of other projects built by Substrate, but that was just a quick overview of the main ones. So back to George.
Okay, so as you guys see, this is kind of the end of the presentation, but it's not the end of this stream. So as for the next steps and what you should do going forward, I think the best places to start are to first build a local blockchain. We'll do that right now on stream. The second is to create a custom palette. You would absolutely need this if you are going to build blockchain using Substrate. So it's good to go through the tutorial and see how it's done the easiest way. And the third, it's kind of optional, but also I invite you to try this out as well, is to deploy your first ink contract. As you can see, all of the things listed here are links. They link to the documentation where these things are described as guides. So let's click on the first one, building a local blockchain. Now, this won't be a code along with me type of thing, mainly because this tutorial depends a lot on things like having Rust installed, having built one of the projects in Cargo, and all of those things can take more than 10 minutes. So yeah, we're not going to be doing them live. They have already been done offline. So this is the page. This is just how to build a local blockchain. It's extremely easy to do. It's absolutely necessary for you to do this. It's just because it's that easy. Now, here it says that the tutorial takes approximately 1 to 2 hours. In my experience, it takes less than half an hour. So just trust me when I say try this out. It's really fast to implement. So what are the first steps that you need to do? The first step is just to clone the Substrate node template repository. The second step is to obviously go into that folder after cloning it. Creating a branch is completely optional. And then you have to build. Now, this building process, as you can see even here, is estimated to be over 11 minutes. Yeah, this is the part that we're not going to be doing on stream, but as you can see, there's not one difficult command so far. It's just copy and paste, copy and paste, copy and paste. Now, once you have done all of these steps, you're basically ready to run your blockchain. This is it. It's really that simple. So all you need to do is just insert this command and the node will run. So let's copy this. Probably not sharing everything, so I'm just gonna quickly reshare the screen. Yep. Should be good now. So here we have I've opened a couple of tabs on the terminal. I'm currently in the directory of this node template. So here we just paste the command after the build has been processed. And what happens is that all the blockchain is now running. So all these things you see here, those are actual blockchain logs. So that means that we can now interact with the blockchain. So the first part of this tutorial was to just get the blockchain running. Now the second part is to get the interactable part of the blockchain running as well. Now for this tutorial, the interactable part, much like the blockchain part, are already done as templates. So we don't need to do any additional coding. We just need to follow the steps. And believe me, they are easy to follow. So here we have the install the front-end template. It does require Node and Yarn in order to run. So as long as you have those, you can get on with it. Once again, we need to clone a repository, enter inside of it, and run yarn install. Now, this takes less time, I would say, than the cargo build, but I've done it offline regardless, because yeah, it's better to be to come prepared. So as you can see, once again, this is just a bunch of very easy to follow commands, and then the server itself starts with yarn start. So let's go here in the third tab that we have opened. This is the Substrate front-end template, as you can see. And here, if we write yarn start, and wait for a couple of seconds, it instantly opens on the browser. So this is a front-end representation of how our blockchain currently is doing. As you can see, we have the current block, finalized blocks. Those numbers do change. They do follow the logs that are written here.
This could be considered as a blockchain scan, like Kita scan or similarly?
Yeah, it's kind of like this, but it also allows you to interact with the blockchain. So here, before interacting, I'm just gonna quickly show what's inside this Substrate node template, so that it's not that surprising. So here we have a bunch of folders. We're going to be taking a look at the palettes template src lib rs file. This is where the palettes live. So if you wanna generate a custom palette, this is where you wanna be generating it. As you can see, this is not meant for production. This is basically just a template to show you how the whole ecosystem works. Down here, we can see, we have the mode palette, and here we have the definition of the palette. We have the different functions that the palette has available to them. So I'm looking for a call here. Yeah, so call is the main function that is exported here. It just takes an integer and does something with it. It's the way that these parameters are named are it just shows you that this is a template. It's not supposed to do something spectacular. It's just to see whether you can easily make an interactable palette. As you can see, this code is mostly inline documentation. It's literally more documentation than code itself. So running this locally, it's very easy to understand everything that happens just because you can simply look at the documentation that it has and you understand what's happening immediately. So this is the palette interactor that you just saw here written on the backend. I won't be showing the front-end part. I don't think that's as interesting. So you need to choose a palette. And of course, this time we're going to choose our own palette, which is the template module. As you can see, all of the other palettes already have names that exist in the palette.
So these are the current palettes, which are default palettes for the Substrate, which is coming out of the box?
There's no such thing as default. These are just the palettes that are included here.
Ah, okay.
But yeah, let's take the template module. This is our module. Of the callables, we only have the calls error, which we don't want to call, and the do something function, which takes in a single unsigned 32-bit integer. So let's say 56. And then I think signed is going to be, yep. And as you can see, we have all the events being here. You have the extrinsic success, you have the fee paid and whatever. Now, something stored is exactly what we want it to happen. Now, we want, when we call the palette interactor with something with the value of 56, we want this to store inside the database a something with a value of 56 and the address from which it was coming from. So, as we can see here, this starts with 5GRWV. This is the first account, Alice. And as we can see on the top right, we are currently Alice. So it is correctly storing the data. Yeah, once again, it's very easy to use. Just, yeah. Now, you can also transfer funds using this method. You have the transfer option here. I can show it again on the front-end side. It's just from Alice. Obviously, we're Alice, so we're going to be sending it to probably someone else. Let's send it to Charlie, for example. We want to send a 5 amount. Now, this is a transaction. This should take longer than the other transaction from the palette interactor. But yeah, as you can see, it's currently sending. I don't know if it will be approved anytime soon. But that's basically it. As you can see, it's very easy to do. The only things I've written in my terminal are literally 2 commands to start both the front end and the back end. And all of the other things are just downloading and compiling building steps.
I guess there is a default configuration for the blockchain with some basic parameters on that.
Yeah, you can. If you're building it from here, from build a local blockchain, yes, it will come with a template that already has palettes included in itself. If you want to start from scratch, you won't have any default palettes. You have to choose, because the beauty of Substrate is that you can replace everything with whatever you want. So then we can at some point stop the node. It doesn't need to run eternally. So that's for the first part of what I want you to do following this presentation. It's very easy to do, as you saw. The next thing we want to be focusing on is creating a new palette. Now, this would take some more time than the previous example for sure. It's not only going to be following easy steps. Sometimes you have to write code, you have to think of some things. You see the amount of documentation and the things that are written here. It's not the same level of difficulty as the previous one, but it's definitely something that you need to check in order to build the blockchain that you want. And after you're done with this, the next thing you can do is just to deploy your first Ink contract. So Ink, it has a very easy setup. I've linked the link to point to the setup page, so you don't miss anything by accident. After you have done the setup, it has a very nice tutorial you can follow on the left, which ends with calling your contract, with troubleshooting technically, but yeah, at the end you'll be able to call your contracts. And once you've done all of that, I would say you're ready to start building your project, or go dive deeper into things like Frontier. It's really up to you. That was the main thing from us here today, guys. So if you have any questions, we would love to answer them. Quick question, is Ink the most used library to write smart contracts on Substrate chains? Yes, it absolutely is. I don't even know if there's anything else that you can currently use, because the Solidity, which you can use for writing smart contracts, necessarily makes you have the Ethereum and EVM palettes so that you can run the Ethereum contracts on Polkadot. So yeah, Ink is the most used by far. Well, looks like there aren't any more questions currently. Don't shy away from contacting us out of this presentation if anything comes up in your head and you just can't find the answer, don't seem to be able to. Another thing I would also advise to new blockchain creators is to take active part in the Discord. And I don't mean answering other questions. I mean, when you have a question that you can't answer, just try in the Discord. It's the best place. It's way better than trying to search for it online in Google. It's not, blockchain is not a sphere that's as prevalent, and you won't find answers to all the questions you're looking for there. But the Discord, there are a lot of guys there with a lot of experience with Substrate, with Polkadot, with everything in the ecosystem. So yeah, if you have problems, just go there. Well, thank you and goodbye.
Thank you.